Good morning, everybody. My name's Nick Fleming. I am a business development specialist for entertainment for CM. Joining me all the way from Lidditz, Pennsylvania is our CM trainer, Brian Leister. Brian, say hi to everybody.
Hey, everybody. How you doing? Thanks for joining us today.
Yeah, great. And then I'm down here in Orlando, Florida at Harp Rigging. They were gracious enough to allow us to put on a training session at one of their sound stages that they use for putting online concerts together. Joining me and acting as our newbie rigger today is Jesse Derlin. Jesse, say hi.
Hey, everybody.
Hey, so Jesse owns Harp, and then back in our switch room, we have Mike McFarland. He'll be doing all the switching on the cameras for today. Mike, say hello.
How's it going, guys?
Yeah, so Mike runs Harp for Jesse. So, Brian, why don't you take it away and tell us about our first moment of training here?
Sure thing. Thanks, Nick. So we're going to take this from the ground rigger's perspective. When they walk into a room, there's points marked, or they have to mark points, and that is a duty usually assigned to the production rigger. And the way that we mark points differs in different areas, different regions, different practices. There's still kind of a lot of tribal preference among riggers out there. But what's important about the way we mark points is that they're consistent and that they match what is on the rigging plot so that we can reference them. And also that the top rigger who's up on the beam can look down and see where their next point is and understand what they're expected to pull up for that next point so they can prepare themselves. So we're going to take it from looking at the point all the way to getting the truss in the air, and then we'll do some load estimations. And we're going to talk about each of the steps, the considerations that go into that to keep things safe for everybody out there. So Jesse, why don't we take a look at where our first point is for today?
Yeah, I have the point here marked on the ground. I don't know if you can see that. It's on your side.
Yep, pretty simple mark.
I did a simple 1-ton point for what we use down here in Florida.
Okay. Now, normally with that, that would be like 1 ton to 120 some people, depending on where you're from. Like I said, we mark things differently, but we would also put on there, if it was a bridle, we would designate the different symbols that tell you what size bridle you'd be building. But today we're just going to do a simple 5-foot basket with a working shackle, and a little bit later on, Jesse's going to show us how we assemble that on the ground, and then how we pull that up over the truss, or in this case, what we're simulating is a beam, and make those attachments. So we were going to break right into a live trivia part right now, so we're going to do that through the chat. So Mike, can we get the first trivia question up on the board? Is that still possible?
Yep, that's not a problem.
All right.
I can send it right now.
Okay. All right, so our first trivia question here was, which one of these is not safety critical when you're putting a truss span together?
So, as Brian said, this was the point where we go find our device and answer the question, but it looks like we may have taken down our platform with the amount of people wanting to play. So all I want you guys to do is shout out the answer when you see it, and then we'll take a look at the chat and see what the majority have said. Oh, my Lord. It looks like this was an easy one, Brian.
Yeah, I would hope so.
Well,
I was hoping to get a couple people that might disagree.
Yeah. Well, I guess the only bad part about doing it in the chat, if somebody wants to be the rebel and go against what the majority is, then everybody will know.
Yeah.
Oh, there's an A. I saw an A in there. Good job, whoever that rebel was.
Yeah.
All right. So it looked like it's a very unanimous C. Brian, is that the correct answer?
Yeah, that would be the correct. And while uniform direction of bolts is a factor in some cases, it's not a safety critical factor. Most of the time, we try to keep all of the bolts aligned in the same pattern, because that helps us go when we're going to take the truss apart or put it together. It helps with consistency. But I have worked with some people who insist that the bolts be opposite each other on a diagonal basis. So your top left and bottom right bolts would be like the head is on the left, but the opposing bolts would be reversed. But really none of that is safety critical as far as any of the information I've come across.
Absolutely. So it looks like we do have some people that were able to log in before the system crashes. So looks like we'll see some of the answers, but the 569 attendees, and looks like we're doing a great job by answering online. So good job, everybody. All right, let's move to our next trivia question. Brian, why don't you go ahead and read it aloud?
Sure. This is about what is the maximum span between supports for a 12-inch by 12-inch light duty utility plated truss. So we're talking about general purpose light duty truss with gusset plates that get bolted together. What's the longest span we can have for that between supports?
Now, Brian, while we're waiting for people to answer, what is the most common uses of truss? You know, are there different types? Are there different scenarios where these types would be used in?
Oh, definitely. There's a lot of different types of truss out there. The most common is probably going to be your plated utility truss or light duty, like we're talking about here. But it's going to come in a variety of sizes. Some of the most common sizes I've worked with are your 12-inch, your 20.5-inch, or the 26 by 30, which is sometimes called PRT. Folding triangle truss is another really interesting one to work with. I saw a comment in the chat there about the bolts from our previous question. I just wanted to throw something out there about that. Someone asked about what way do you put the bolts in a vertical leg? And I would say that is where that is an instance where I would argue that there is a more safety preference for that, where you would want the head of the bolts on top with the nuts on the bottom, so that if for some reason the nut loosened off and fell, the bolt's still going to remain in place.
Got it. So, Brian, it looks like this was a much harder one. It's almost hard to judge, but I'd say the majority have said a B, but there was quite a few that have said A. So maybe you can go over the differences.
Sure. And, this is based on about, 4 of the most popular or most prevalent truss manufacturers out there, which I'm not going to name, of course, but most of us, probably know who they are. Their load tables are going to restrict you to a 40-foot span between support points. Now, that's not the entire length of a truss. That's just the distance between, the supports or the motors or the rigging. There might be other truss manufacturers out there that make truss that is, lighter duty, that they say 30 feet is the max, but 40 feet seems to be the norm.
Very good. All right, so it looks like we're ready to move into step 2, which would be the truss handling and the layout. Brian, why don't you take it away with that?
Yeah, we're going to get into what we do when we put the truss together, how we make sure that it's safe for use. And, in a real scenario, all this stuff happens very quickly. So what we're doing is we're drawing it all out to give a perspective of what our riggers need to be thinking of and looking at as they're putting all this stuff together. So let's take a look at what Jesse's doing with putting his truss together there. Yep, he's going to be putting that truss together. But while he's getting those bolts in place, let's take a look at some examples of damaged truss, things that, let's see if our audience can pick out some damage here.
Yeah, that's right, Brian. So we got 3 different trusses that Jesse pulled out of his retired pile in the back. Each one of those has a different marking on it that would require it to be retired. So we'll go ahead and get some close-up views of that. And when you guys spot it out, just call out the color and what the indication would be that you might need to be retired. And we'll see if we can't get all of them together. And Brian, while they're doing that, why don't you keep going over what some truss inspections might be?
Sure. Like our trivia question inferred, the truss needs to be laid out so that the diagonals form a continuous pattern. So each break in the truss where it's joined to another section, those diagonals should form a nice continuous pattern, because the diagonals are there to help share the forces throughout the truss between the 4 different chords. Because truss, on a very basic level, is just 4 pipes, 4 aluminum pipes, and those pipes combine their strength together through those diagonals and ladder bars. So we want to make sure that that pattern is continuous.
All right, very good. So it looks like everybody's chiming in. Looks like obviously the easy one was the dent on the green. So if we can show the dent on the green real quick, that way everybody can see what we were talking about there. Good. And then the second one was definitely a decent. I thought this one would be harder, but everybody got it pretty easy. Was the bent diagonal on purple. So if we can show the bent diagonal, there we go. And then the last one, I didn't see too many people answer this one, so this one must have been pretty hard. Maybe it's the camera angle, but there's a C-clamp mark that's pretty indented there on the bottom cord there. I don't know if it might be you haven't got the right light on it to make it noticeable, but those were kind of the 3 different indications of what we would need to retire that. Now, Brian, how would you measure something like that?
Well, if you're looking to find out what the tolerance is, like how much of a dent or gouge that you can have in a truss, You're not going to find that information in the standards. The standards remain pretty vague, so they don't, call out specific manufacturer information. But I would contact the manufacturer of that truss and ask them for those values, like how much, material can be worn away, or how deep of a gouge can I allow in there. And when it comes to some components of the truss, like the ladder bars and maybe the diagonals, some manufacturers actually do make it to where those can be repaired. You send the truss in, you get it removed, they put a new one in, and you're good to go. And that's going to be a decision to be made about, how much does it cost to ship it, get it repaired and all that versus the cost of a new section. But what you don't want to do is continue using truss that you suspect is damaged.
Mm-hmm. Very good.
Now, Jesse just joined those trusses together, and we're looking at the bolts there. You got those tightened up. Some of the other things that we should be looking for here are some kind of evidence of inspection, right? We need to know, just like our electric chain hoists, the truss has to be inspected on a periodic basis. So Jesse performs his frequent inspection as he's laying it out, putting it together, and we're looking for evidence of a periodic inspection by a responsible party as well to make sure that that truss has been deemed safe to use by a qualified person. Some additional things that we should consider is that, let's say those two pieces of truss, while they are the same size, might have been made by different manufacturers. That could be an issue. Some production companies will, say their policy is no, you cannot use different manufacturers in the same span. But I know in the entertainment industry as a whole, we tend to do this pretty regularly, when necessary. And what you have to keep in mind if you're going to mix manufacturers of truss in a single span, there's two things to keep in mind. One, identify whether the individual manufacturers do allow for their truss to be bolted to other manufacturers' truss. And second, if they do, you're going to have to go by the lesser of the two capacities listed for that type of span. All right, Jesse, are you all ready to go? Did you get everything bolted up?
Yeah, I got everything bolted. I do have a quick question that, so when I bolted it, I don't know if you can see here, I used some of these cut washers and then some regular round washers. Does it matter if I mix those up?
Well, the washers will be proprietary to the types of truss. It depends on the interior room of the gusset plate. So when you put those washers in, are they sitting nice and flush to the gusset plate material, or are they like at an angle because they're sitting on the side of a weld?
No, everything is flush with this model truss that we're using.
There you go. That's important. Now, I know there is a rather popular truss manufacturer that their gusset plates do require that you use the cut washers. So you should definitely identify, which type of washer is compatible with the gusset plates on that truss. So
Okay.
what'd you use to tighten up those trusses? Hand tools, I hope?
Yeah, hand tools. I don't do power tools. I know some people choose that method.
Yeah, I would never use power tools on the truss. One of the things that's going to happen there is you're going to end up with a lot of cross-threaded bolts and things like that. Plus, it's really loud. When you put that truss together, I noticed that you used a wooden block to get the two gusset plates nice and even. And that's a great practice because the other ends of your truss are sitting on like a base or something like that kind of made them tilt. When you're trying to join trusses together, you want to try to do whatever you can to make sure they're nice and flush when you bolt them, because otherwise what's going to happen is you could end up cross-threading a bolt, or you'll also end up wearing out the holes in the gusset plate, making those larger. And that could be a reason to end up possibly retiring that truss over a period of time. So now that we got our truss together, we found our point, we know where our motor is going to go. The next thing that we're going to do is a quick recap about truss handling and inspection, along with some standard information. And then we'll be moving into getting our points built and everything. So here we have some information for everybody about the relevant standards. A lot of the entertainment standards that have been developed over the last decade or so, you can find those on tsp.esta.org. They are free to download, unlike a lot of the industrial standards that are out there. You won't find a lot about entertainment-specific information in the OSHA regulations. although it is still really important to be aware of OSHA regulations. So some key things about truss handling and use are to never drag the truss or slide the truss along a surface, especially the backs of trucks or concrete or anything like that. You want to make sure that you have a partner help you carry it if it's too heavy. Look for evidence of recent periodic inspection. All right, there is a requirement that these trusses get periodically inspected, and that inspection needs to be documented. Perform a frequent inspection before you use the truss. Check all the cords, the ladders, diagonals, the gussets or forks if it happens to be the type that has a fork and pin connection. Take a look at any welds you can see and look for damage and cracks, distortions, things like that. Anything that you find suspect should be removed and replaced with something else. You should never put it in the air if you suspect that it's damaged. Make sure your diagonals form a continuous pattern, and make sure you're also familiar with the manufacturer's requirements and the load tables associated with what you're doing. If you got to mix manufacturers, it's not recommended, and it could be prohibited depending on your employer or the manufacturer. But also realize that you're going to have to use the lesser of any load tables provided for that type of truss. All right, Nick. So we're going to be getting into the next section here.
Yeah, absolutely. So, Mike, if you want to roll the next trivia question, and again, everyone, just go ahead and chime in on the chat board there what we think the right answer is going to be. This is going to be surrounding pre-operational checks of our hoist. So I'll be watching the chat board here, and you guys just start responding when you get the right answer. Brian, if you want to read the question to him while we got time, go ahead.
Which symbol must be embossed on the load chain to verify that it's manufactured by CM and approved for use in the hoist? Now, for our folks that are outside the U.S., they might not see the correct answer on here as it applies to them. So we will talk about that while the question's going. In the EN 818 standard, there are different requirements for the way load chain is manufactured for hoists. And so that certification process is going to be different. And that hoist will be labeled with an H. It'll be like a cursive, fancy looking H with the number 22. The H signifies that it was certified by BG Proofcert, a German certification body in Europe. And the 22 is the number that they assigned to Columbus McKinnon. But here in the States, we have a different requirement for our chain, and we've been doing it since 1967. Did everyone get a chance to answer our question, you think?
Oh yeah, absolutely. So this is a pretty unanimous slide for C. But before you go ahead and tell us the right answer, we just did it anyway. Just want to remind everybody that's watching us on Facebook, if you want to come join in this chat and this interaction, just go to Harp Rigging /training and harprigging.com/training, and you can join the action as well. All right, Brian, it looks like the landslide is definitely C. So I'm assuming that is the correct answer. Yes.
Yep, that is the correct answer. I'd like to talk about the wrong answer of A. That disc chain, that's going to be a different kind of chain and not for electric chain hoist. And one of the key differences there is that that would be a through hardened chain that goes into like a manual product or rigging chain for like hanging loads. The chain we use in our electric chain hoist is case hardened. So that what that means is the outside layer of the chain has been heat treated, but it was quenched before the interior part of the metal was hardened. And the reason for that is the dynamic forces that happen inside the electric chain hoist. We want that metal inside the chain link to be a softer metal, more prone to elongation before rupture. So that's what we use there. And Jesse's showing us the star. That looks like it's reading pretty well on screen there. That's what the star is going to look like on your chain. So any load star in North America, that's going to have a star on there. But if you're out in Europe, different standards are going to have an H22 on the chain instead. Those are the only two marks that qualify for use in loads in CM hoists.
Good, great. All right, so Mike, let's go ahead and roll the second trivia question.
While operating the motor, you hear a rapid chattering sound coming from the brake end cover. What is the likely cause of this noise? All right.
So Brian, while they're reading that, what do you think of our new black phosphate chain?
I think it's a great product for theatrical use. That's what it was intended for. so we could keep it, nice and unseen
Right.
in our theatrical applications. But I've seen it being used in a variety of different venues now.
Yeah, absolutely. How about you, Jesse? Have you had a chance to see it and play with it yet?
Definitely, I do like it because you can hide it easily. I'm still a fan of the old school shiny chain. I like to see big shiny chains in the air, but that's me. But if we need a hide chain, absolutely.
Absolutely. Yeah. Okay, great. So it looks like the answers are all piling in here, and it looks like the majority have said C, but there are a few that have chimed in with A. So if we can go over the differences, that'd be great.
Yeah, I'd like to touch on each of those actually, because
Okay.
they're all different symptoms and different troubleshooting steps that you might need to take. If you've got a slipping clutch or load limiter, that's not going to be a chattering noise. That's going to sound like a kind of a weird scraping noise, but it'll be a constant noise. A worn chain guide, you could end up with a cyclical scraping sound, but the chain guide area where the lift wheel is and the bearings associated with it, if any of those components are worn, the frequency of that sound will be a lot slower. That's the slowest moving component inside the hoist. The next fastest moving component would be your gears, where the load, or in most cases where the load limiter is, unless it's a next gen load star, and then our clutch is going to be out by the rotor stator. So in the transformer being blown, you're not going to hear anything because it's not going to work. You're not going to have any voltage going to the control circuit, so nothing's going to happen at all. So low voltage to the brake is the answer we're looking for here for two reasons. One, the brake is located under the brake end cover. And when the brake doesn't get enough voltage, which could be from too long of a control cable to pinched wires, loose wires, maybe too many motors trying to run on the same circuit, those are all causes for that. And what you're going to hear is a very rapid clicking noise as the brake tries to open and close very rapidly to allow the hoist to run.
Okay, very good. Well, it looks like I guess we're ready to move on to our next phase, which is the pre-operational check of our hoist. Jesse has brought out some of his older hoists that may have a couple of Easter eggs worth of issues for you guys to find. So as Brian is going through with the training portion, if you guys see something that might be wrong, go ahead and call it out, and we'll address it as we see it.
Yeah, before we jump into that, I wanted to talk about a comment I saw come up on the chat. Someone had said motors without gravity switch inverted will chatter also. And the reason I want to bring this up is what that references is the square D contactor, which is one of the original contactors used in the Lodestar. When the Lodestar was brought from industrial to entertainment, it had this contactor that only allowed you to use the hoist in one direction. So what I want to tell everybody is that the entertainment standards published by ANSI through ESTA are they do require that the motor be used motor up and motor down, that you'd be able to use it in either direction. So that would be one of those things I would want to address with any inventory that that I have, to make sure that motor complies to those standards if that's your company's policy.
Very good.
So our next step is to get Jesse to get this motor pre-operational check. So he's what are you looking for there, Jesse? What's the first thing that you think you should find?
I'm actually looking for any obvious damage to the casing itself, or leakage, dents, anything like that is just stands out.
All right. Well, while you're doing that, I'd like for our virtual riggers out there to see if they can find any inconsistencies or red flags that stand out to say, hey, that needs to be fixed or that needs to be looked at. Has that hoist been inspected?
Yes, it has. Let me look at the date here. Less than a year ago. So yeah, inspection's still good.
All right, so we have evidence of a periodic inspection. That'd be the first thing I look for. Another thing I'd be looking for, Jesse, is to make sure the welds on the chain are facing the right direction. All right, and so for a Lodestar, all the Lodestars, no matter what size they are, we want those welds. If you look along the line of chain, there's a side of each chain that has a weld on it. And those welds need to be facing away from the lift wheel. All right, so away from the dead center of the hoist. When you look at the very center of the hoist and you have the two chains, just go ahead and pull the two chains up so they're parallel. When you look at the center line between those two chains, you want to make sure that the side of the chain links that is facing that center area are the smooth sides of the chains. Hey,
All right,
Nick,
they definitely are.
do we have any response from our virtual riggers? Did they find any of the Easter eggs we left for them?
Absolutely. I think they found our Easter eggs and a few more. So,
Okay.
yeah, absolutely. So the one that they found that was pretty prevalent is on the plug. Looks like there might be a loose plug on there, a loose connector.
They are correct.
Yep. Yeah, and that's a hint that maybe somebody grabbed that cable to try to move the motor or lift it. And based on the responses we've been getting from our virtual riggers out there, I think that the majority of them know that the handles, the cables are not handles. But it does happen from time to time. People do grab onto those. Luckily, this is a quick fix for Jesse. He's going to take off that plug. He's going to take a look at the wiring, make sure nothing got pulled out of its contact. And hopefully he can reseat that cable installation and get it fixed up.
Absolutely. So while he's doing that, we'll go over another one. Looks like a lot of people have said the chain bag hooks need some attention. Can you talk about that?
Yep. And I find a lot of people, I mean, obviously not the people we have online today, but a lot of people I've worked with don't understand that this is a potential safety hazard for the hoist. We want those chain hooks or the hooks on those chain bags to be facing outside. So the nose of the hook, the opening side of the hook, needs to be away from the chain. All right. And the reason for that is there is possibility, as things move around, that chain could catch inside that latch, and the power of the hoist would just really peel that hook right open, maybe dislodge the chain bag, and then we could lose it. So looking at the two things we just talked about, the electrical cords and the chain bag are two things that we should always be checking. Besides pulled insulation or anything like that, we want to look for burn marks, bent prongs, cuts and tears in the insulation, things that might designate that the hoist had some kind of electrical problem or incurred some other kind of damage. And we want to make sure that is checked off our mental list before we put any kind of power into the hoist, right?
Yeah.
And then when it comes to the chain bag, we want to take a close look at that as well. Get the attachments in the correct orientation, and also look for holes, cuts, and tears. Those chain bags get dragged around quite a bit, so they can get torn up pretty bad. But also some of the lights that we use nowadays can burn holes right into that material. And then if we have chain running out in the middle of show when the hoist is in the air, that could be a major safety hazard.
Yeah, very good. So I saw someone in the chat said they've never seen a hoist with added handles, and I think the guy doesn't know what he's missing.
Yeah, that's definitely a big deal. Since I've been working at CM, I've been harping on the designers and the engineer guys going, why don't we put handles on here? Why don't we put handles on here? And the best answer that I got back from it, as it relates to our end users out there and our riggers out there, is, as it stands right now, we don't make handles all incorporated onto the hoist when we manufacture it. But our channel partners, our distributors, the people that you get the hoist from, most of them, if not all of them, have a variety of different handle kits out there. And when it comes to handles, there's a lot of preference. I've worked with hoists that have handles that are angled at 45 degrees. I've had handles like the ones you see here. I've had soft handles that were nice and cushy with a grip.
Right.
So the fact that we can give you the hoist and you can choose the handle types that you want, I think is a better offering than just us deciding what handles are best and giving them to you.
Yeah, every one of our distributors can put those handles on for us.
Yeah, definitely. Yeah, they have the information in the product to be able to adapt that hoist for you. So if you're ordering new ones, you can ask them to have handles on them before they arrive. If you're sending in existing hoists, you can ask them to add handles to it. But the other big reason we don't put handles on there is that if we put extra handles on things, people might try to rig from them. So
Yep, absolutely.
Hopefully we're all smarter than that.
So Brian, we got two more one that's pretty common was they focused on the chain, saying it looked a little rusty, maybe a little dry. If our chain is rusty, how could we possibly remove that rust?
Well, if you've got some surface rust on there, that might not be a big deal. You can probably easily remove that. I would start off with a soft medium, like a nylon brush or something like that.
Right.
And if that doesn't do it, maybe a wire brush, but be very cautious of it. Don't put the chain up against a wire wheel or anything highly abrasive, because remember, it's case hardened. You don't want to wear away that hardened layer on the outside of the chain. But I think the best way to remove chain rust from chain that's got rust all over it would be through a tumbler. And I think the guys at Harp have one of those. Maybe we can take a look at it later. I don't know if I don't know where it is in your facility, but it's basically a cement mixer without the blade inside. And what we do is we strip the chain of any hardware. We put it in the mixer with walnut shells or various other light abrasive things that aren't going to scratch up the chain. And it does a number on the chain. I mean, it'll take chain that, like what you're seeing here on screen, and make it shiny and new. So it's a fantastic way to clean off chain.
Yeah,
but
very good.
It's pitted. If you've lost actual material of the chain from the rust, that's got to be taken out. The only way to avoid that is to lubricate the chain. You got to lubricate it on a regular basis. And that lubrication, most importantly, needs to be between the links on the chain.
Where the metal meets the metal, right?
I see somebody pointed out we're missing our tag.
About time. I was hoping, but maybe it was our camera angles that was kind of hiding it. But I was surprised not too many people caught that one at first. But now at the nice shot of it, maybe we were hiding it on them. But yep, we're missing our ID plate.
Yep. Yeah. So I just want to remind our virtual riggers out there that we are trying our best to keep up with your comments and everything. So if we don't address something that you might have said, we do have we might be able to follow up with you later in the Q&A. But there is a latency. So what I'm saying is, when you hear it, I've already said it like 15 to 20 seconds late. So we are trying to keep up with your comments and everything. The ID tag on there, yeah, that's a requirement of the ANSI standard that we're going to talk about shortly. And you've got to have that on there. It's got to have certain pieces of information like the capacity, the wiring setup, the manufacturer's contact, stuff like that. So that needs to be maintained on the hoist. And, you should contact your distributor for a replacement tag. Very good.
I think that's about, I think I got most of our comments. I know there was a bunch of comments about missing a strain relief. Is a strain relief a necessity?
Well, the strain relief, usually what we'll do is we'll put a ring on one of the break end cover screws, and then we can clip our motor cables to that. So usually the motor cable has like a dog clip or something that we can tie it into. But if our cables don't have a strain relief, we can use some tie line and maybe attach it to the handles. But in this scenario, we don't really need a strain relief, because what we'll do is we'll dress the cable along the truss. So the cable's not taking weight. The strain relief is really there to make sure the cable doesn't pull our connectors or our cords out when they're seeing the full weight of the cable, like maybe in a ballroom setup where you're gonna strip the cables off after you hang the truss.
Absolutely. Okay. Well, Brian, do you want to finish up with the inspection, or did we cover everything?
Sure. Well, we'll do a recap just to make sure we talked about everything.
Okay.
When it comes to the lubrication, it's going to be Lubriplate 10R is what we recommend. Now, we do realize that in some situations, in some environments, there might be substitutes that are used. But what we test with in our lab is Lubriplate 10R. If you need to use something beyond that, you're going to have to, and you want to maintain your warranty, you're going to have to discuss that with your warranty service center and with CM if you have some kind of other needs.
Very good.
So we're going to go over our recap real quick. We'll talk about some of the stuff that we addressed here. The relevant standards that you'd be looking for electric chain hoists in the entertainment industry are E1.6-2 as far as inspection and maintenance. And then the selection and use is covered in E1.6-3. So those are your two entertainment standards that you can find on ESTA.org. And then our pre-operational checklist, kind of a mental checklist that we have to have here, is looking at the electrical cords and connectors for damage. Look for recent evidence of a periodic inspection, right? A sticker or some kind of label that tells you it was inspected. Look at the chain, make sure that it's lubricated, it's in good condition, and that the manufacturer's mark is there, and also that the welds are facing away from the lift wheel, and that's for load stars. For Pro Stars, different story. Welds face towards the lift wheel on a Pro Star. Verify the right phase and direction of operation. So while I'm reading this through, Jesse, why don't you go ahead and get everything plugged in and make sure that motor runs in each direction as it corresponds to the pickle or controller that you're using. All right. The reason that's important is when the power phase is reversed on the hoist, when we push up and it moves down instead, what's happening there is the phases have been reversed, but the limit switch inside the hoist is physically still moving. And what that's going to do, if you keep operating it like that for any length of time, you could end up breaking your limit switch right off. In my classroom, in Rocklitz, we have a handful of broken limit switches and broken travel nuts from the limit switches because of this kind of mistake.
So, Brian, if I could break in for 2 seconds, I think one thing that's very you can kind of see it on video. He's kind of hiding behind the truss there, but he's not plugging his motor in before he gets power from his distro box. You want to talk about that for 2 seconds? I see that way too much in the field that people are plugging in hot motors.
Yeah, a lot. The show has to happen, and we have to move fast and all that. But we should still take relative safety precautions with electricity. And I would advise not to plug the hoist into anything while the breakers are live. So make sure the breakers on your distros are off. Get your cables plugged up, everything sorted out before you send power through that cable. Yeah, we're looking at the body of the hoist for damage and lubricant leakage. So look along the gasket lines, make sure that there's no gouges, that the gasket material forms a nice seal there. We don't want grease getting out, but we also don't want other chemicals getting in. Take a look at your chain bag, make sure it's installed properly, there's no damage. Look at your hooks and suspension hardware. All right, check them for wear, damage. Make sure that the hardware is in place and that it's not like, some random bolt someone threw in there. And then your latches. We got to have latches, and the latches have to be operational for that hoist to be safe to use overhead. So that's their general pre-operational check of the hoist. And we encourage you to go find some of the standards related to that. So Jesse, we got the hoist runs, right?
It does. And I just double checked it for up is up, down is down. So we look functional.
Excellent. Very good. So we got our truss in place. We've got our hoist verified that it's safe to use. And our next step is going to be getting our hardware laid out on the ground for our uprigger. And before we do that, let's go ahead and ask some questions to our audience, some trivia about that process.
That's right. So everybody can get their trigger figures ready for our next trivia that's going to be surrounding rigging to our top points. As Brian just mentioned, we're getting our gear ready. But before we do that, Mike, you want to mention to everybody on Facebook where they can go to join us and interact with us if they'd like?
Yeah, sure. If you guys are watching on Facebook, you guys can go to harprigging.com/training and join our chat here and enjoy the conversation. And you guys, here's your next trivia question.
Which knot is used to attach the rope to the rigging assembly for easy installation by the top rigger? So for perspective, we're talking about your basic 5-foot basket with a working shackle type scenario.
So Brian, being that these are all about knots, didn't we just put something out on Facebook for Rig Safe on tying knots?
Yeah, I did 7 essential knots every rigger should master. We threw that out on Twitter, Facebook. I think it's on LinkedIn. And pretty soon there's going to be a full blog article on our new website that we're coming with.
Yeah, very good. And what's your for tying knots and whatnot, what's your favorite type of rope or favorite type of diameter?
Well, in a lot of cases, I'll use a double braid rope, usually 13 or 14 mil, something nice and thick, easy on the hands if I'm pulling a lot of points. But otherwise, I would use an 11 mil kern mantle rope because its knotability is very good, its strength is very high, and it can be used in a lot of other situations besides rigging points.
Very good. So note to self, I see somebody asked, where's the tie a lot answer? We don't have a tie a lot answer.
Right.
All right. So, yeah, it looks like the landslide has come in with, we got to make these questions harder for these guys because they're pretty good at what they do, it looks like.
Yeah, sounds like it.
Yeah.
Yeah, the bow line is the right way to go. I did see somebody in the chat mentioned a clove hitch on the chain, and that's actually featured in the blog article that we're coming out with. Is one other kind of obscure use of the clove hitch is to tie it on the chain. And And that's great for when you have an established point and you want some slack in the hook so that you can manipulate it properly. So that's also a possibility. But the bowline is the go-to knot for hauling up your basket with a working shackle in there. And that's what Jesse's going to be showing us now.
Yeah, very good. So before we get into the next section, Brian, excuse me, we got one more question, don't we?
Yep.
Yep. So let's roll the other trivia question.
At which location in the picture would a ground rigger tie in their rope? So we got four different potential areas that you could tie it into.
I bet you we get a few different answers on this one. So while you guys are answering that, looks like we're going to be running a little bit behind today. So hopefully you guys can hang with us as long as you can. All these questions are phenomenal, so we don't want to pass up asking any of the good ones that the majority have asked. But it's definitely putting us a little bit behind. We're totally fine staying. We hope you are too. But just wanted to throw out that warning that looks like we'll be going over our hour time today, which is great. I love the interaction. I think this is exactly what we were hoping for.
Yeah, in this trivia question, there's only one right answer here. And the reason, well, I think we've given everyone time to answer, right?
Yep, and it looks like the landslide is A. However, there's quite a few for B's, and then even a few C's trickling in there.
Yeah, so let's take a look at that in the picture that we're looking at here. The right answer is A. If you were to tie it into B, then yeah, you probably could get the point up in the air. You could probably make the basket, but when you lower it back in and the basket takes weight of that chain, what is most likely going to happen is your rope is going to get pinched between the eye of that steel and the shackle, and you may not be able to get the rope back out depending on how much weight's on it. Another possibility is C or D, and either one of those options is going to make it nearly impossible to get that point up there with the rope in place, because in option C, the bowline is going to move that working shackle up and out of the way, and you might not be able to manipulate it. In option D, that's where we're putting the pin of our working shackle. So if our rope is already there, we stand to either have a very difficult time getting the pin in there, if at all, and also the rope's going to be in the way. So
okay.
Option A is the right way to go here.
Absolutely. All right, well, I think we're ready to move on to our next section, which would be our section 4, rigging to our top points. As we mentioned, we're taking social distancing very seriously. So this is one of those moments we may have to use our imagination a little bit, because poor Jesse, playing our newbie rigger, is going to have to play both the uprigger and the downrigger role. So while we'll try our best to make sure we differentiate when he's playing downrigger and when he's playing uprigger, but it'll be pretty easy to figure out. And secondly, we wanted to make sure we got you guys enough really good shots of what he's doing as an uprigger. So right now we have a little goalpost set up in front of us here, or behind me, excuse me. But we'll have to pretend that the top of that goalpost truss is a beam 60 feet in the air. So we'll have to put our imagination hats real quick just to make sure we get through this. But we want to make sure everybody's staying safe and keeping their distance and not sharing tools and whatnot. So without further ado, let's go ahead and turn it over to Brian.
Sure. So let's take a look at what you rigged up there, Jesse.
All right, well, me being my first day on the job here, I think I might have messed something up. I don't know.
Oh, yeah, there's definitely some Easter eggs in that, too. Shout it out when you see it.
I think it looks right, though. I got the pin facing up. I don't know. What do we got here?
Yeah, we'll give our virtual riggers a minute to pick apart and tell us what's going on wrong here with Jesse's picture. But in the meantime, how long of a bowline did you tie, Jesse? About how long is that loop?
This one's a little bit short. I'm probably 4 foot, 5 foot on this.
Yeah.
Most time about 6, but I think I might have messed that up too. My upriggers would be really upset with me.
Yeah, and the length of that bowline is going to depend on a couple things, such as the dimensions of the beam. The larger beam or smaller beam. It's also going to be dependent on the uprigger's preference, because what they have to do is they have to pull that knot over the beam into the other side, and then they're going to put their foot in the knot to hold everything in place. That way they can bend down, make the point hands free, and then when they lower the point back in, the knot of that bowline still needs to be somewhere they can reach it. So we're going to kind of demonstrate that in just a minute. But it looks like a lot of people are pointing out that there's a ton of problems with what you got rigged up there. So let's go ahead and fix that up.
Yeah.
Hints for you. You're going to want the pin of a shackle into that hook.
Okay.
Yeah, it looks like our virtual riggers caught it all, Brian. Looks like
yeah.
Yep, the rope was in the wrong spot and the shackles are in the wrong spot. They're kind of related, but yep, that looks like another easy find for our guys. Now we know we're dealing with some really good riggers here. We'll have to really stump them next time around.
Yeah, and while Jesse's getting that fixed up, I'd like to just touch on the subject of why it is so critical that the ground rigger is able to, first of all, keep pace with the uprigger and a keen awareness of their surroundings, as well as keeping all their operations consistent. So the primary biggest job the ground rigger has is maintaining the load hazard zone. So the area that is underneath the work being done above, making sure that no unnecessary personnel are walking through that area. And if they are, that they have proper PPE like hard hats and stuff. They're also there to make sure that they keep up with the uprigger. The uprigger's got a very important job, a very difficult job. While it may not be super complex, they need to know what they're expecting to get. Because if I'm up 80 or 100 feet on a beam and I've got to pull all that chain up, that's somewhere in the neighborhood of like 120 pounds, depending. And if I have to pull all that weight up there and I find out the ground rigger didn't tie the knot right or put the shackle in the wrong place, well, now I got to lower it all back down and haul it up again. And I might have, a dozen or more points to pull that day. And it is not easy work.
So Brian, it looks like our newbie rigger struck a nerve with our virtual riggers with swapping pins.
Oh yeah.
Yeah. They
don't like that either.
They don't like that either.
No, I can't make these guys happy.
Yeah. See, the problem there, Jesse, is that your working shackle could get down there and get caught on the pin there, and that can also get in the way of the uprigger's ability to make those connections. So that shackle needs to be spun 180 degrees.
Fine, guys.
Yep.
Jesse, how's it feel to play newbie rigger in front of 600 experts?
And also, Jesse, while you're at it, before you make that connection, let's go ahead and turn that eye-to-eye steel around. You see the eye-to-eye steel, the other end of it? Does it have a tag on there?
It does.
Yeah, so a best practice would be to have that tag where the hook is, so that when the uprigger is going to handle that other piece of steel, they're not having to manipulate that tag, because that tag always ends up getting in the way. And sometimes the little wire rope they use for it can prick your finger too, and that can be an annoyance. So our job as a ground rigger is to make things as easy and safe as possible for those around us, as well as the person who's working up above us.
There's a lot of people asking for your termination already, Jesse.
Oh, man.
So you've messed up too much, newbie.
Yeah.
No, this is great. And I, in all sincerity, I do appreciate you playing the newbie rigger, Jesse.
I know. I'm going to get beat up after this.
It's great conversation.
So Brian, so get our bowl inside. So what's going to happen now is Jesse is going to change hats. And he's going to be our uprigger. So Jesse, for about 2 minutes, you're going to get a nice premium rate. But after that, you go back to being paid, whatever it is you make now.
Actually, before that, I need to throw some burlap in this. But our rigging box actually had two different types. We have our traditional that we've had for 100 years, probably.
And then we have we're about to blow up the chat again, because one of those two things in your hand is trash, and the other one is acceptable.
All right.
That piece of brown burlap you've got in your hand, that is what I would call kindling, because should a pyrotechnic device, a spark from one of those, or a bad connection in a cable, anything that could cause a spark or high heat situation, if it catches that burlap, it goes up like a match. And we've demonstrated this here at our Rock Lidditz training facility with our neighbors who do special effects in pyro, and they have shown how these things just go up like crazy. So definitely get rid of that, throw it away. Okay. And what you've got in your right hand, where'd you get that from?
Actually, I got this from our friends at ARS up there in Atlanta. They say it's fire retardant.
Oh, cool. Yeah, if you're going to use burlap, and me, I'm giving you my personal opinion here. I'm not a burlap fan. I like engineered products. I like products that are manufactured specifically to protect the wire rope. But I do understand our industry has a fascination with burlap. So we're going to go ahead and use that today. And the key thing here is that it's been fire treated. That's the biggest hazard that we have with using that old dried out burlap that we find on shows. All right. So, here we go. Start the clock, because now you're an uprigger for,
Perfect. Let me put my uprigger hat on here. Yeah.
Let's go ahead and pull your point. So the situation that we're showing you guys now is not 100% realistic to what you'd be encountering, because you'd be sitting on that truss, and you have to imagine that truss is an I-beam. But the mechanics are still the same. Jesse's going to pull the knot over. Normally, he would put his foot in the knot. He'd bend down, get that steel around the beam, and then make his connection from the eye of the steel to the shackle. And it's really important that before he lets off tension from that rope, that he gets that burlap, his edge guard there, so he can protect the wire rope from being cut against the beam. All right, and a single layer is not sufficient. You want to make sure you're trying to create a pillow there to create a barrier so that the edges of the I-beam aren't cutting into the steel.
I'm a little short today, but I'll get there.
Nah, that's all right.
So, Brian,
Now,
I noticed that looks like half-inch steel. Is there a preference between half-inch or 3/8 or?
3/8 is very common when we're doing 1-ton points. But if you're going to be using 2-ton points or anything heavier than that, half-inch steel would be a good way to go. And I'm hoping that maybe some of our virtual riggers will notice that we're using that half-inch steel with 5/8 shackles. And while the capacity is not an important issue here between the different hardware choices, the way they fit together their compatibility is what we're looking at. When we use 3/8 steel, we use 5/8 shackles. When we use half-inch steel, we should be using 3/4 shackles. And the reason for that is so that the shackles don't have a chance to rotate inside the eye of the steel and end up being cross-loaded.
Very good.
So he's not out now, and now he can pull his rope back through. It's not pinched or caught or any kind of hazard. He can get his rope cleaned up and move on to the next point. So good job, Jesse.
Thank you. I'm going to milk this up here for a little while, try to get that extra pay.
Yeah, go ahead. That's fine. The last thing I want to talk about is the debate about mousing, to mouse or not to mouse. And I'm sure, again, the chat's going to blow up about this one. While I haven't read any specific directives or standards or regulations that say you have to mouse the shackle, a couple things to keep in mind are, first of all, the manufacturer. Does the manufacturer's information say you have to seize the pin, right? If it does, then guess what? You got to do it. If the company you're working for or the venue you're working in requires that all shackles be moused, and I used to work for one that did, then guess what? Yeah, you got to mouse those shackles. But when it comes to the effectiveness of whether or not the mousing is going to make a difference, in this particular scenario, those two shackles that are up there, they will always be seeing load, and they're always going to be seeing pretty much the full load of the chain plus whatever else we're going to hang. Now, a shackle that's under load is not going to inadvertently roll out unless it's being affected by an outside force. So when that shackle has a couple 100 pounds on it, you're probably not going to be able to remove it without anything other than a very large wrench. So does mousing add safety? In most cases, yeah. In this case, it's debatable. But again, it depends on the policies of the people you're working for and the products that you're using.
Very good.
All right. So now that we've gotten our top point in there, we're going to be moving on to Jesse doing some rigging on the bottom. So while he gets his hardware ready, we are going to recap real quick. And someone did ask, what is mousing? Mousing, I do have a picture of that coming up after the next section. But mousing is a method of seizing the pin and tying it to the body of the shackle so that it can't unroll itself. It can't unscrew itself. All right, that's what it means. And it can be done in a variety of ways. So our pre-operational check of the hoist we've already done, and now we're talking about our rigging assemblies. Now, we don't have any specific entertainment standards published right now through ESTA about this component. So we are going to talk about the ASME standards, and in a few minutes we'll be tapping one of our industry professionals to give us some more background on that. But the ASME standards that you see on screen, you can find those on the ANSI's web store. Things to keep in mind when we're rigging our points for the top rigger are to inspect all of our hardware. Make sure that there's no damage, no wear. Make sure you understand how to inspect that hardware. And one of those things is to be able to make sure that you can identify the manufacturer. There has to be some kind of permanent fixed labeling on that shackle from the manufacturer, and make sure your pins are matching the bell of your shackle. All right. People do use different manufacturers of shackles, and sometimes the pins and the bodies of the shackles can get mixed up. So if you want to know if your shackle is a proper CM pin, then our manufacturer mark will be on there. It'll say CM. There'll be a trace code, usually a 2-digit or letter code. And then after that, it's going to say HS on it. And HS stands for high strength. That means all of our pins, regardless of the metallurgy of the different shackles we have out there, other than like, stainless steel, maybe, they're all going to be high strength super alloy pins that are basically interchangeable among CM shackles of the same size. Check compatibility of your components. We did identify 1/2-inch steel was used with 5/8 shackles. So there's a potential there for the shackles to roll through the eye. So the best practice would be use 3/4-inch shackles or 3/8 steel with 5/8 shackles. Never exceed the safe working load limits as designated by the manufacturer. That is your hard stop. Yeah, we know it takes a lot more to break that object, but you are only allowed to use the working load limit. Use the PRES method, the press method, when you're putting your points together, and we've illustrated that on the bottom right there. Press stands for pin, rope, eye, shackle. So if you remember that acronym and you can connect it visually in your memory, you should look at your point every time and say that's how it gets set up. Evaluate wire rope protection materials for fire resistance. Make sure you're not using stuff that's going to catch on fire. The one thing we don't want in flames is the thing that holds everything up over our heads. And then finally, double check all your connections and knots before sending up. It's also a great idea if you have a fellow rigger around to say, hey, check my points while I go move to the next one. Second set of eyes is a really good thing to have to make sure everything stays safe. All right, we're going to move back to Jesse. He's got some rigging going on there. All right, Jesse, so you're rigging to the truss, and let's see if our virtual riggers can come up with any commentary regarding how you set up your slings.
He's gonna win back your faith. I can see it. And I tell you, let's give him a good opportunity to take a look and find some things, and then we'll go to our trivia.
Sure.
I think it's good. It'll hold, right?
You have Jesse. Jesse's going to win back the love of the team. Yeah, so let's give him a good shot, a good look, and then we'll go to our trivia here.
All right.
And then we can cut back to it as well. So, Mike, why don't you go ahead and cut to the first trivia question, if you would.
Yeah, not a problem, man. Guys, if you're watching on Facebook, you can go to harprigging.com/training and join in on the conversation. Here comes the first question.
Which size and configuration of sling would be the most efficient and represent best practices for rigging points on a 12x12 truss? And yeah, we realize that some of these options, while feasible, might not be the best practice here.
Yeah. So go ahead and shout out the answer when you see it, guys. And Brian, let's talk about how many different kinds of slings are there? I know there's 3 and 6 that are pretty common, but how many different types are there?
Yeah, well, when it comes to synthetic slings, you're gonna find slings that you could have flat webbing slings or round slings like we use. But the 3 types of connections that you'll typically see on them are going to be an eye-to-eye sling, similar to that steel that we use, but in a synthetic form. A reverse eye that's meant to be choked or girth hitched around an object. But what we typically use are called EN slings or endless slings, where it's just a complete circle, and that's the most common.
Okay, so it looks like we're flooding in with our answers here. And it looks like B is the prevalent one, but we did have quite a few for C, so maybe we can explain the differences there.
Yeah. Each of these answers, yes, you could perform the function that you're trying to do with each of these. The 3-foot sling basketed to the top cords, that is not the best way to go here, because one, you don't have the redundancy of using 2 separate slings, which is a good practice to have. But also that simple basket going through the cords, if the truss is off balance at all, it's going to roll forward and backward, and it could slide left to right as well, depending on how the loads are balanced and such. The right answer was 2 3-foot slings choked to the bottom, wrapped around the top. That is the go-to method for this kind of application. If you took one 6-foot sling and went around the entire truss in a basket, what you're going to achieve there is like the maximum strength of the basket and maximum strength of the truss because you're capturing all the cords. But what you sacrifice there is you open yourself up to some hazards. So first of all, the truss can slide through that sling. So if it's on the end of a truss, you might lose that point entirely. Second, if that point slacks off compared to others, and that's normal to happen when you raise a multi-hoist rig, the bottom portion of that basket could end up caught on like a C-clamp or some other object on the truss and end up getting cut, torn, or maybe even dislodging that object. So what we want to do is keep those slings nice and tight, secured to the truss with some grip on them.
Very good.
Yeah.
All right, so let's move on to the next trivia then.
All right. So when you're rigging points to the truss using synthetic slings, what else is required to make the point safe and ready for lifting?
Okay, very good. And it looks like for our virtual riggers, we're coming right up on our hour mark from when we started. So again, if you guys have to cut off, we totally understand. Looks like I would say, what do you think, Brian? We got maybe 30 minutes left before we do just open it up to general Q&A.
I've got all day.
Yeah, I know you got all day, but I'm not sure everybody around the world's got all day. So if you can hang out with us, keep hanging out. Looks like we got about 30 minutes left of training, and then we'll open it up to a real large Q&A because I know there's lots of questions that people are looking to get answered.
Yep. Yeah. So the we put some kind of silly answers in here as well. Some things that like, why would anyone do that? Like using a white zip tie to mark the point as complete and inspected. I think that's an interesting one. But the right answer here is that we're going to incorporate a wire rope sling, and Jesse's going to demonstrate that for us now. The reason that we are going to do that is because these synthetic materials, while they are very, very strong, they are still susceptible to heat, fire, sharp and abrasive contact. So the more tension that sling's under, the more easily it can be cut and torn. And we also can't use those slings in any environment where we have exposure to more than 180 degrees. That's when they start to degrade a bit. So what we're going to do is put an eye-to-eye steel in there. So let's cut back to Jesse and see what he's got going on.
All right. So
let's
looks
take
like
a look at his wrap.
our virtual riggers found some things, Brian.
Yeah, what did we find?
Our virtual riggers found that there's something wrong with the tag laying against the truss itself.
I put the tags out so you guys can see it. That's not a good thing? Not good practice?
Well, I can see it. What does that tag say right there?
Yeah, good intentions.
Is that a
but
5%
the reason
tag?
that we don't want that tag involved in that kind of contact there is because it has nothing to do with whether or not the sling is weaker or stronger or anything in that area. It has everything to do with we have to preserve that tag as best as possible, because once that tag has become illegible, that sling is now garbage. So we want to keep the tag in a place that it doesn't have any kind of stressful contact with the other parts of the rigging.
But I
And
do like
while you're
that.
fixing that-
Sorry,
what's that,
Brian.
Nick?
I do like that Jesse showed that it's a FiberTech tag, because that's I think that's a Silver State Wire rope made product, another one of our distributors. So free shout out for them. So good job on the sales tactic there, Jesse.
And then the other thing that Jesse had done there, you can see that his bottom choke on that side was on the interior of the truss, and then he took the sling up and wrapped it around the outside. And while that's not like some huge safety issue, we want everything to be consistent. It will alter the overall length of his sling. So it's going to kind of cheat his sling a little short on that side, which could imbalance the truss. And it's also it could press up against a diagonal and cause a bend in one of your diagonals. So if you're going to wrap around the outside, like he has now, make sure the collar of your choke. Can we take a look at the bottom of one of your slings there?
Yeah.
And let's take a look and identify what the collar is. So that's what I'm calling the collar of the choke. You want that to be on the same side as the direction of your wraps around the truss. So, Jesse, let's take a look at the top of your truss and see how you wrapped those top cords.
Fired.
That brings up a whole new question.
You're
what happens
fired.
when you drop a shackle? I don't know if we want to open up that bag of worms or not.
So you've done two different styles of wrap here. On your left, or the downstage side, you've got what I call a through wrap. So you took the end of the sling through the two sides of itself. And on your upstage side, your right-hand side, it looks like you did what I call a sidewinder wrap, where you wrapped outside the sling ends and kind of moved your center of gravity a little bit. Either one of these is actually just fine. And we do use them in different applications. Some people might argue that a through wrap causes too much friction between the sides of the sling. Other people might argue that the sidewinder wrap changes your center of gravity on what part of the truss is taking load. Either one of them is just fine, but what we do want to have is consistency. So I find that the sidewinder wrap can be a good technique when you need to cheat the point over a little bit along the truss to line things up properly. But this is what I typically go with, which is a choke on the bottom, collar on the outside, one wrap around the outside. All right, and we're using 3-foots here because they mate best with a 12-inch truss when we need, the headroom and stuff like that. And Jesse's going to imagine we are using a steel core synthetic sling in this case, but we're going to pretend for a moment that it's just polyester round sling. And we're going to show you one of the go-to ways of adding a piece of steel into that rigging setup. You see that Jesse kind of basketed over the top and then brought the two ends up through the inside of the truss. And the reason for that was he's trying to take up some of the potential slack that steel would have should the slings fail in a fire situation or damage situation. Then we want to minimize the amount of drop distance, of free fall distance that truss is going to experience before that eye-to-eye steel catches it, right? And that precaution is there to buy us just a little bit more time to, vacate the building or, for first responders to get to a safe area, that kind of thing. So it looks like you got your point all rigged up. You got some great feedback from our virtual riggers. And I would like to pick someone's brain today because we did talk about the differences between polyester round slings and steel core slings. So I'd like to bring in our good friend Rob Bruno, my counterpart here in CM. Hey, Rob, how you doing today?
Pretty good, Brian. Yourself?
Pretty good, man. We've talked a lot about this subject in our rigger boot camps that we do here at Rocklet. Up until lockdown, we were doing those once a month, along with some hoist boot camps that were a lot of fun. But I know this conversation came up quite often regarding the steel core synthetic sling issue. And I think Jesse found a couple slings in his inventory that he was going to use today that he's not too sure if they're safe for use. So maybe you guys could run through that and talk to us about that inspection.
Absolutely.
So yeah, Rob, I found this sling. I inspected the sling. Everything looks fine. There's no tears or anything. It's actually a steel core. Feels good, but unfortunately, I can't read the tag at all. Like, it is not legible.
Yep. So when we're looking at slings, we're going to follow an OSHA regulation, which is 1910.184, which covers slings, as well as an ASME standard, which is ASME B30.9. They both state that the sling tag must be present and legible. So even though the tag's there, if you can't read it, it's no good. So you have to remove that sling from service and cannot use it for a rigging application.
Okay, copy that. All right, I have a couple other ones. I can read the tag perfectly fine. They look somewhat new, actually. But unfortunately, I don't think they're good. But you're the expert. You tell me if showing some of this bare wire inside is a good thing or not.
Yep. So because those slings are tagged like a polyester round sling, in other words, on the tag, it's going to state that the cover is polyester and the core material is wire rope. So they're tagging it like a round sling. So we're going to inspect it like a round sling. Removed from service criteria, and that is any holes, tears, cuts, or snags in the cover that expose the core yarns, which would be the wire rope, or any damage to the core yarn. So the fact that you could see that wire rope interior core yarn in there, for lack of a better term, means it needs to be removed from service and you can't use that sling.
Okay. Then also, let's just say if I didn't have that hole or that tear, I got some good kinks in this one as well. It looked like it was used and abused a little bit. I could feel it all the way through.
Right. So the standard reads for your polyester slings, any knots inside of the sling, except for those made during the manufacturing process. So we can kind of defer a little bit between the polyester standard and wire rope standard. So because removed from service criteria for wire rope is a kink, and that's a polyester round sling, we'll kind of combine the two and say, hey, the kink is no good. You don't know what damage that has caused that internal fiber or internal wire. So we're going to go ahead and remove that one from service also.
All right. So these are definitely going in the trash. Thank you.
Yep.
Great. So that has been kind of a gray area for us, Rob, and we appreciate you helping us clarify what the current standards say regarding those kind of slings.
Thanks, Rob.
Absolutely.
We find those used a lot in the industrial world.
Yeah, we use more polyester round slings. We don't use the steel core round slings. We prefer the polyester as they're easier to rig with and choke with and things like that, as we rig and unrig a lot more than the entertainment guys do.
Yeah. Cool. Well, thanks a lot for your input there, Rob, and making some time to jump in and on the conversation with us.
Absolutely.
We're going to the recap of this step real quick. And as Rob mentioned, there's some ASME standards that relate to this, same ones we talked about for the hardware we used before. And on the bottom right of the screen, someone had asked about, what is mousing? And here's some visual examples of it right there. The black shackle you're seeing, we're using 0.032 inch stainless steel safety wire and a special tool called a mousing plier, which isn't required, but it is a very convenient way to mouse shackles. And then on the right side, that silver shackle, that one's been moused with a tie wrap. So, not considering the company policies that you might be working under at a venue or with a company, these two methods are typically used. The tie wrap method is typical of a temporary install, and the wire method is typical of a permanent install. But we do make shackles that have a bolt, nut, and cotter pin in them, and those are designed specifically for permanent use, for permanent install use. Whether or not you mouse the shackle is still debatable, but I will say my personal preference in my professional rigging experience has been that the points to the truss should definitely be moused. And the reason I say this is because you might have a truss that has several different hoists on it. As that goes into the air, the loads are going to shift between those different hoists, right? The heaviest hoist will run slowest. Other hoists might be, seeing very little to no load at a given time. And during those no load or light load situations, that's when that shackle pin is subject to and vulnerable to rollout, to where the pin can unscrew itself. And that could be acted upon by things like, heavy bass music, maybe while the audio team is running noise through a lot of the speakers and stuff, or cables that are being pulled around and moved. Gravity helps assist with that pin rolling out as well. So any shackles that could experience a no load or under load situation, those are the ones that I would target for mousing. And the reason I'm avid about this is because I have seen a shackle pin drop from the truss to the floor once. It's super rare. Not a lot of people, experience that, but I have experienced it. And that sold me on the idea of mousing all my bottom shackles. But some points we want to talk about are inspecting our hardware again for damage and wear. Everything we put up over people's heads, we got to check it, make sure it looks good and it's the way the manufacturer intended it to be used. You want to rig at or as close to possible to panel points on the truss. And a panel point on the truss is where the diagonals converge. That's the strongest member structurally along the truss. Most manufacturers are going to say they want you rigging to those areas. So you want to rig at or close as possible to those areas. Use a wire rope to back up your synthetic rigging from heat and sharp or abrasive contact. Position your sling labels to prevent damage and wear. Make sure that they're visible and legible as often as you can. And mouse your shackles where appropriate or where you are compelled to by company or venue policies. Evaluate your sling configurations for the most efficient use. Look for hazards associated with the way that you're rigging your slings, and check for unnecessary compression of the truss. That's something that happens a lot in ballroom situations or areas with low headroom. We try to really get the angle of those slings as flat as possible. You have to realize that when you do that, you're going to be putting a lot of compression on the truss cords and could end up bowing the truss. I've retired dozens of sticks of 12 and 20 inch truss because of compression from slings pulling them inwards like that. So that's something that you want to be very cautious of as well. All right. So that's our recap. Nick, why don't you set us up for our next trivia section here?
Absolutely. So the next step we're going to be doing is just footing our truss to working height. So these questions are going to kind of somewhat surround floating our truss. So Mike, why don't you go ahead and roll the first trivia question, please?
Sure, Nick. And also, if you guys are watching on Facebook, you can go to harprigging.com/training to join in our conversation here. And here comes the first question.
What should be done once the truss has been elevated to a working height position?
So, Brian, I know, let's talk about your boot camp that you have at Rocklitis for 2 seconds, because I know, a lot of the stuff that we're talking about here today is just barely touching on what you guys cover in your basic rigger boot camp. But why don't you go into that for 2 seconds, because I think that'd be pretty valuable for folks to know.
Yeah, the amount of content and how in depth we get to it to compare is like when you go to the grocery store and you get like one of those samples in the aisle. That's what we're giving you today versus what you would experience in our rigger boot camps. We do a 3-day rigger boot camp, very intensive process, full days each time. And we focus a lot on safe rigging techniques, how to use all the hardware that we would be using. And then we do pretty much a full day on rigging load estimation. So we cover simple load calculations, we cover cantilevers, bridles, and all that information as well. And then we wrap things up with fall protection. So we do a basic fall protection kind of awareness training, but it does have a lot of hands-on stuff as well, where we perform a rescue. So we have our dummy set up and we do a rescue of that. We do some tower climbing and rescue from tower climbing as well. So it's a pretty in-depth class and a lot of people really enjoy it. The best thing about it is we've kicked it up to a monthly occurrence as opposed to quarterly. And we've reduced the class size down to 10 people to give everybody more opportunity for that hands-on activity.
Okay, very good. So it looks like our answers are in. Looks like almost unanimously is D, but we did have quite a few for C. So I don't know if you want to go through the differences there, Brian.
Yeah, I mean, in some perception that you could say that these things are kind of happening at the same time in a way. While the other crews are putting their instruments and stuff on the truss, we're going to be going around checking the bolts. But remember, we're taking this from the ground rigger's perspective. So the ground rigger should not be installing anything themselves until they've completed their task of making sure all those bolts are tight. And the reason why we redress the bolts at this point is because when the truss is on the ground and we tighten all the bolts, once we lift it in the air, the forces distributed through that truss are going to change. And that can cause some of the bolts to become loose. So it's important to go around and designate a specific person or persons to check each and every bolt for tightness. Whether or not you torque them with a torque wrench, that is debatable, and that's something that you should address directly with the manufacturers.
Very good. All right, let's roll to our next trivia question.
Right. Which method of securing cabling to the truss is most widely accepted as a best practice in temporary rigging scenarios?
Very good. And I think, Brian, we might make this one our last trivia question because we're so far behind. But we have some more loaded up. So maybe at the end, after we say goodbyes, those that want to hang around for the Q&A and talk some shop, maybe we'll ask the questions then just to have some fun.
Sure.
All right. Very good. So is there a universal height for floating a truss? I've always wondered if there's a standard rigging working height for floating a truss.
There's a universal range. It's usually somewhere between 4 and 5 feet. I mean, you want to be courteous to your shorter and your taller crew members to make sure they can reach everything they got to reach. And you also have to account for like lighting instruments or any other objects you're hanging under the truss. You got to make sure that there's enough clearance for those. While the truss is somewhat in the air.
All right, very good. Looks like we got our answers in, and pretty much A is the predominant winner. I don't know if I saw many of anything else.
Yeah, some of those other methods are just silly. I would definitely kick you off the crew for zip tying the cables to the truss. One, that's going to make load out a lot more painful and create a lot of trash on the ground. But also, you could end up, when you're going to cut those tie wraps off, you could end up cutting your cables, which would be a bad thing. The other two methods are not that great. Now, we do run cables through trusses sometimes for special reasons, but that's very rare, and there needs to be a reason for that. And one of the reasons we don't want to do it is when we go to pull those cables out later, they're going to be smacking every ladder on the truss as we're pulling the cables through, which could damage the truss and the cabling. So our typical thing is to lay the cabling along the top of the truss, secure it onto the truss with tie wraps, and not tie wraps, with a clove hitch and a half hitch, using some like 1/8 inch sash cord or tie line. That would be our go-to method for that.
All right. Very good. All right. So as we said, our next step is going to be floating the truss. So Brian, why don't you take him through floating that truss for him?
Sure. All right, Jesse, we got our motor ready to go, right?
Yeah,
our other side's already been rigged. We're going to rig this one up now. And then after we get that rigged up, we're going to talk about some load calculations and stuff like that. So, Jesse, before you get any tension on that motor, one of the things I'd like to let you know is, yeah, there you go. You're putting the motor closer to the point. We don't want to drag the motor. We don't want to put that kind of lateral tension there. It could shift our upper point, but more importantly, what could happen is once the motor does get off that cart, it could swing, and that uncontrolled swing could cause injury or damage to other people. You've also put yourself in a good position where you're not between the motor and the truss. That way, if there is an uncontrolled swing, you don't end up on your butt. All right, so we got our motor up in the air, and we're going to get it down there and hooked onto our truss there, our rigging point. Someone did ask about the 4 different objects inside that shackle. Ideally, we do want to minimize how much stuff we have in a shackle. In this case, this is considered acceptable practice because the eye-to-eye steel pieces aren't taking any load. So what's important there is that they are on top of the slings, not under the slings, so that they don't get damaged. So that the slings don't get damaged when load is taken.
So Brian, we've had a couple questions on dressing cables on the truss. Do you mind maybe running through a couple tips for dressing cables?
Sure. You got to talk with the other leads and the rest of the crews that are working, because they might have special requests or special needs. They want the audio cables and the video cables run on separate sides. Before you start running cables and commit to that process, there might be a curtain or some other kind of object that needs to go there instead. So you got to make sure that everyone understands what piece of the truss they get when they're running their cables, especially in a situation where you got to troubleshoot the signal or power issues. You don't want to have to be, digging through loads of cable to try to find your connectors and stuff.
Yeah. Thank you.
All right. Looks like we got us all rigged up there. Jesse, have you checked our motors from the multi-hoist control system that you've got yet, or are you just running from the pickle?
Just the pickle for right now, but I'm actually switching over as we speak.
All right. So running in this situation, Jesse's got a power cable that is a 7-pin cable that runs power and control for his multi-hoist system, but he's got that spare pickle cord sitting out there too. And one of the things that you could encounter is maybe your hoist runs up and down just fine when you're running off the pickle, but there could be a problem with that 7-pin connector, and maybe it's not talking to the hoist control system. So that's something that you should be watching out for as well. Make sure it operates from the primary system.
So Brian, I just bumped both my hoists up and down, so separately they run perfectly fine.
Great.
So I'm ready to bump the whole thing up just to make sure they run together.
Yeah, and you'll find language in the ANSI entertainment standard, E1.6-3, that talks about individually bumping the hoists up and down. So you got to make sure they run up and down. But another important step is to make sure they all run together after you've individually bump checked them, because when you're running multiple hoists on the same circuit, you could be overloading that circuit. Maybe you've got bad cables, or maybe the amperage just isn't high enough. And you could have, like say you've got 20 motors to run, you might have 1 or 2 drop out when you try to run them all at once. So always double check the full system before you've committed.
All right, so I bumped them individually up and down and together up and down. So my bump checks are done. Next, I think I'm ready to fly. If you guys are ready for me.
We are. What's something that you should be doing right before you push that button? What do you want to do?
I look around my surroundings, make sure everything's safe, nobody's underneath the truss or can be harmed. And then I shout out truss flying, or whatever your method of informing everybody is.
Yep. Yeah, you want to alert the crew. Make sure that everyone realizes the truss is moving.
All right, so truss moving.
All right, looks like we're up at working height. We're going to do a quick recap of the principles that we have discussed so far. Some relevant standards that you could find about portable control of fixed speed hoists, ANSI E1.6-4, and then entertainment technology recommended guidelines for rigging inspections are listed there as well in .47. And then there's also an international code of practice for entertainment rigging that is something that everyone in our industry should be familiar with as well. And all those can be found on the ESTA website. When you're doing your floating of the truss, make sure that you position the hoist and yourself to avoid uncontrolled swings and maintain secure footing. Double check all your rigging. This is your opportunity to go around and make sure that everything is good before you send it out. Individually bump check every hoist in both directions and do a group bump check to make sure you have enough voltage to support the full system. Double check all your bolts, make sure they're tight. Verify all your cabling is secure and won't interfere with any of the operations or other instruments. Make sure that anything that anybody else puts on your truss, the lighting, the audio, the video, the scenic, whatever it is, make sure that any instrument or object attached to the truss has some means of a secondary attachment. It's got to have something in case its primary attachment fails. And then look for loose items left on the truss, right? Maybe someone put their tablet on there or left a big stack of gel frames or a tape measure or a truss tool. So go around, make sure there's nothing that got left on the truss that could later on fall down and hurt somebody. And then before you hit that button, alert the crew that truss is moving. Be loud and assertive when you do that. So that's our recap for that part of the step there. And it looks like we're setting up for our load estimations.
All right, truss moving.
All right, so Jesse's rigging up his truss right now. What are you rigging up there with? What is that object you got that you're about to hang?
We need some good amount of weight for this test. So this is one of our test skids that we use for our mobile motors. When we inspect hoists, we travel around a little bit, so we had to build a custom skid.
Pretty cool. So you guys made that or what? Did you have someone make it for you?
Yeah, we actually made it ourselves. That's the good thing about our facility. We do have manufacturing in-house as well. So when we do need something random, we get it done quickly.
So you guys use that? You guys use that for what? Periodic inspections on site?
Yeah, we travel around to different theaters and whatnot. That the biggest thing is if they only have like a one-day downtime, they don't have enough time to get to our facility and back. So we'll just drop down 8 hoists, inspect them, and get them back up in the air.
That's cool.
Yeah, that's pretty convenient. That's awesome. You guys have a machine shop, maybe able to make your own test weights for your motors. While Jesse's getting that rigged up, we're going to go through some rigging math. And this is kind of the first basic formula that we address in our rigging math portion of our rigger boot camps. This is how to calculate the load of a point load on a simple span. So we have a determinant structure, meaning it's a straight truss on 2 points. We have a point load, and then we'll sketch out everything in terms of what we need to know. So things that we need to know are the span. That's going to be the distance between your 2 supports, the 2 motors. We need to know the distance between the first point, A1, and the load or object that we're hanging, and that's going to be D1. And then the distance between that object and the far anchor, which is going to be D2. We also have to know the weight of the object we're hanging. So how much of a load are we putting on there? And then what we're going to do is plug those numbers into these 2 formulas to determine how much of that object's load is going to be applied to each side. Now we've separated F1, which is the force on the anchor, from the object, and the value for A1 and A2, because what A1 and A2 represent is the cumulative load. So we want to figure out how much of that object's load is going on the anchor, and we also have to account for the weight of the truss and the weight of the hoist, etc. So the way that we set all this up, if we want to find out our span and our D1 and D2, that's just as simple as running a tape measure and measuring those distances. If we want to find out the weight of the object, well, we shouldn't be hanging anything that we don't know the weight of. So use your internet connectivity or product manual and find out the actual weight of the object that you're going to be hanging. And then the self weight of the truss and the hoist in this scenario, we can just look at the self weight of the truss and apply half of it to each anchor. And then the motors themselves as well. We can find their weights and account for those. So we're going to start off with a starting weight on A1 and A2 of 270 pounds because that accounts for the truss and the motor, and then 200 pounds starting weight on A2. And then our distances are, the span's going to be 11, the D1 is 3, the D2 is 8 feet, and then our force applied is 250 pounds. So the object we're hanging is 250. Then all we have to do is plug those numbers in to this formula. So it'll look like this when you first start, 250 times 8, finish that part and then divide it by 11. So that'll look like 2,000 divided by 11. And when we finish that part of the formula, we're going to get 181.8. So that is how much of the 250-pound load is being applied to anchor number 1. And then when we go back to our stage setup later, anchor number 1 is our stage right side. So just for point of reference. So we take that 181.8, we can round it up to 182, and we'll add that to the known existing weight on that anchor, which is 270, I think. And then we want to find out what the load is on anchor number 2 or force number 2. And logically, we could just take our 250 and deduct 181.8 from it, and that would tell us how much of the load is left to be applied to anchor number 2. But I like to just make sure I like to check my work. So what I'll do is I'll run the numbers again using F2 instead. And one thing I want to make sure that everyone's aware of, a very common mistake with this formula, is that when you go to find F2, you have to use the distance related to the other side, the opposite side distance. So if you're looking for F2, you're going to use D1. If you're looking for F1, you're going to use D2. And that's just the way that that formula breaks down. Keep in mind, anything with an F represents a force. Anything with a D represents a distance. And the letter S will always represent your span. All right, we'll plug the numbers in. 250 times 3, divide that by 11. That's 750 divided by 11. And then when we solve for that, we get 68.2. Now, to verify that you've done everything correctly, all you have to do is add the results for F1 and F2 together. And if they equal FA, then you know that you did all the calculations right. So then we'll add our FA value or our F2 value to the existing load on anchor number 2. And we should be seeing something in the neighborhood of 268.2, give or take, the accuracy of the load cell. Before we move back over to the stage, I do want to present an idea for everybody to understand. If you have several objects that all have a similar weight to each other, and they're grouped together and spaced rather evenly apart, which is pretty common for us, you don't need to run the formula for each individual object. You can take that group of objects and find the center of gravity. So find out where the objects start on the truss and where they end on the truss, and find the center of that. Use that to measure out your D1 and your D2 values, and then take the cumulative weight of all those objects. So if they're all 200 pounds each, your FA value is going to be 600 for the formula. And that way, that's a quick and easy way to account for a group of objects that are a point load on the truss. All right, so now that we've talked about that, we're going to go ahead and get back to the stage. Jesse's going to lift our weight, and we'll take a look at the dynamometers. So, Jesse.
All right, so we're all rigged up here with some weights. Grab my controller here.
Yeah, and as he's getting ready to do that, notice how the motors are leaning, how they're like tilted. The reason for that is the weight of the chain in the bag is overcoming the balance of the motor. So that's perfectly normal, and we can use that as a way to visually check our motors to make sure that they're actually taking some load. So let's go ahead and fly it out, Jesse.
All right, truss flying.
All right, so we're off the ground.
We are off the ground. I don't think we're perfectly level, but I don't know if that matters. Does that matter in your world for weight?
Not for the purposes of our load estimation. When we tilt the truss, we're not going to see a transfer of load, any significant transfer of load, until we start to get past 30 degrees and into the 45-degree zone of angle. You know, a little bit of out of level is not going to change much. Now, having the truss level in general is a good practice, you know, for working on the truss and for having it level for lighting focus and things like that. So let's take a look at our A1, which is going to be our stage right side, the side that's closest to the load. So it looks like we've got 450, somewhere in the neighborhood of 450 on there. Now, we are using some old school analog load sensing devices, dynamometers. Dynamometers don't just measure load, they also measure the dynamic force. So if you look at that red needle, that tells us the maximum amount of force that that point experienced while he was lifting. So remember, in dynamic situations, when you're moving an object, you are going to experience higher loads than, you know, what you're the physical mass of the object. And as long as you're operating within the safe working load of your hardware and the rated capacity of the hoist, those dynamic loads have already been accounted for in the design factors of what we build and what we use. But it is good to know that we do have an increase of load while we're moving. So that's something that we should keep in mind. So it looks like we got about 450 on that side. Let's take a look at the other side and see what we got there. Looks like it's...
I don't know if you can read that too well on your side, but...
I want to say that's 275.
On the stage left side?
Yeah, that looks like 275 to me.
Yeah, probably pushing 290 even. But
awesome.
I could be off. I am getting old.
So when we did our load estimations, it looks like our formula came out with a value of 268.2 for that side and 452 for the other. So we're pretty close to where that formula says we should be. And I want to stress to everybody that when we do these formulas and things like that, it's an estimation. We can't call it a calculation, because as we raise that truss up, things are going to change. And additionally, any load sensing devices we use, even if they're electronic ones, still only have to meet a plus or minus 2% of accuracy. And that accuracy is not based on the live load that you're applying. It's based on their total capacity. So it's a good choice to select your load sensing devices to have a range that's closer to the actual loads that you'll be working with, so that your accuracy is more close to reality. And also to account for the fact that, you know, it could have plus or minus several hundred pounds depending on the accuracy of that device. So there we go. We've gotten our truss in the air, so to speak, and we've gotten a load on it. We did some estimations and all that. So Nick, what do we have next to talk about?
I think that about wraps it up. Is that a mountain production bag I'm seeing on one of those hoists there?
Yeah, we got a little bit mixed match of bags and parts. I mean, being a bigger rigging company, you get a little bit of everybody's stuff over the years.
Absolutely. Well, Mountain Productions is another good partners of ours, so they're one of our good distributors as well. All right, yeah, I think that about wraps it up. So again, everybody, we're going to stay later for a Q&A for as long as we need to. You know, we got a lot of questions to answer. Obviously, we won't get to everything, but we'll definitely stick around for a little bit of time to just talk shop, do whatever we got to do. As we said, we had a couple more trivia questions locked up and rolling, so if that's something that the group wants to do, we'll be glad to do that. We sure appreciate everybody sticking around so long. We know we went a good amount over, but I think the interaction, the questions, and the answers that we went back and forth with, I think were very valuable. As I said, apologize tremendously that we weren't able to play trivia live with you guys, where we could have crowned the smartest rigger of the room. But we'll work on that and figure out why that one went wrong for next time. We'll sending you guys a survey probably in the next day or so. Love the feedback on this. As I said, this was our first time trying to do this type of interactive type of environment. If you liked it, let us know. If you didn't, let us know what we can change. Because I think we definitely like the interaction part of it. So hopefully you did too. But anyway, we know there's room for change. We know one of the things we're going to do different is the registration next time. We know we've had some feedback that was a little difficult to understand. So, but yeah. Without further ado, Brian, you got anything to close it out?
You know, there's a ton of more information that, you know, we could have gone into today. We really stretched the amount of time that we wanted to keep everybody involved and engaged here. So, you know, never stop learning. No matter how long you've been doing this job, if you ever think that you've learned everything, that's the day that you should just get out of the business. There's tons of material out there, tons of books, online stuff. But always remember to just doubt everything. Doubt everything I told you today. Check it for yourself. Check it against what other people say. Don't just take everything at face value in this job, because what we do with overhead attachment and rigging, it's for entertainment, it's for fun, but it has real consequences when things go wrong. So take the job as seriously as possible.
Yep, absolutely. Great. Jesse, can't thank you enough for opening your facility and playing our newbie rigger today. Anything to close it out?
Well, first off, I want to thank CM for coming in and helping us with this. You guys are definitely the gurus, so you know a lot more than us. I think I played my role pretty well today as the newbie rigger.
All of it was planned, right? Wink,
oh,
wink.
Absolutely. I did not mess up one time. Actually, I'll take credit for that shackle. I totally did.
Yeah, you had a bunch of people on there that wants to know when they're getting their 567 beers.
Yes. I want to thank everybody tuning in today. I know it was kind of last minute. I think it's only been out for about a week, and we put this thing together. So hopefully next time it's better, especially with the trivia. That would have been awesome today if it worked properly. So somebody's getting earful after this for sure. And then I also want to invite everybody, if you're ever in Orlando, I know some of you guys are overseas and whatnot, stop by Harp, see what we do here. We are a full rigging service facility. We do on-site rentals, everything else as far as the service and inspections in-house. Then also by popular demand right now, we're doing more trainings and retail sales have been going through the roof. So both of those are just very exciting for us.
Great, absolutely. Well, thanks, Jesse. As I said from CM, we sure appreciate you letting us come down here and put this on. This is our first step, I think, into something really cool. Mike McFarland, thank you for sitting back there and switching the cameras up for us. Anything to add?
No, I just wanted to tell everybody thanks for joining us, and Harp is honored to be a part of this training.
Yeah, absolutely. And thank you, everybody. Thanks to the camera crew. Thanks for the people online interacting with us. And like I said, this isn't goodbye for us. We're going to stick around and just talk shop, answer some questions that maybe we didn't get to. So you feel free to log off now. Feel free to do whatever you would like to do. But we're going to stick around and see what kind of questions we can answer. So thanks, guys. All right. So let's see what comes up. Brian, you pick out the first one that we can see. We don't have this scripted or even thought through, really. This was very much so. We had a lot more attendees than we thought. So we figured we at least have an opportunity to answer some questions that we knew we weren't going to get to with the amount of attendees that we had.
You had a script?
Well, we had a decent plan of what we were doing, but that plan obviously went out the window.
There's a question that came up in the chat that it kind of got buried a little while ago. Someone asked, before we sign off, can we address the question about the chain bag? I'm trying to figure out. I was looking through the chat to see what that specific question was, and I'm not sure. I couldn't find it. So if anyone, I think the person's name was Kat that asked about the chain bag. If you're still around and you want to jump in with that question again,
Ryan,
let us know.
Why did we put the chain bag inside of the truss? I'm not on the outside.
What's that?
The question was, why did we put the chain bag inside of the truss and not outside of the truss?
Oh, yeah, that's a good point. And you know that comes down to what you're trying to do there is place the chain bag in such a way that the chain will drop into it nice and freely without obstruction. So if you put the chain bag on the outside of the truss, it might still work just fine. It all depends. I mean, if it was 20.5-inch truss, it wouldn't. But what we don't want to have happen is for the bag to deviate away from the hoist to where the chain could spill out. Because once you get a couple feet of chain spill out, you're going to lose the whole thing. And that could cause an accident, could cause some injury. So that would be why we made that choice in this particular instance. Someone else asked if is there a difference between using sling versus a hardware solution like a truss pick, and whether or not you have to back that up? Truss picks are awesome. They do tend to run a bit more expensive. Most of them are solid plates of aluminum, which can be pretty pricey. As far as backing them up goes, that I can't speak to because we don't manufacture those. So talk to the manufacturer of it. But if you look at the reason we're backing up the slings in this instance is we are pretending for a moment that they're synthetic, not steel core slings. We're backing them up for fire and cuts, tears, abrasions, right? So if
So
you're
Brian,
using a pick, you don't need to back anything up for that purpose.
so I want to talk about the pick a little bit. Actually, I have a broken Truss pick. I don't want to bring it out and show any names of where we bought it from, but I do believe in backing it up with steel. Absolutely. If that did break in the air, we would have been definitely in trouble. So definitely believe in backing up Truss picks.
Yeah.
Yeah, so that would be a choice right there for the production rigger, and the company, what their safety policies are. I'll admit that I've hung truss for years and with truss picks and never even considered backing them up because the ones we were using were like so robust. They were solid pieces and we had so many points on the truss. And our normal method or our normal approach to rigging a multi-hoist system is that the failure of any single point in that system doesn't cause the overload or failure of other points in the system. So we have so much redundancy just through the capacity and placement of the hoists that even if that point failed, nothing critical would have happened, or nothing catastrophic. Maybe a piece of clamp would fall out of the air, and that's not ideal, but it's not the same thing as an entire truss system falling.
So, Brian, I know one of our first questions out the gate was talking about shackle identification. I know we kind of touched on it, but I do think Jesse has some examples of shackles that may be unmarked or have marked with China. Do we want to go into some detail on that one? I don't know how well they're going to be able to see it on the screen, but
Let me
might
actually
be
put on
valuable.
my nice service cart here.
While he's getting that set up, somebody has chimed in a couple times about powdered graphite for the chain, and I do want to repeat that the manufacturer's recommendation is Lubriplate 10R. We do realize that other alternatives might need to be used, so you do need to take that into consideration as far as increasing your inspection frequency. So maybe if it's such an environment that you're doing that in, maybe you're doing your periodic inspections on a severe case basis where you're doing it every 3 months and doing your frequent inspections every week. Measuring for wear and stuff like that. So that's the only real guidance I can give you for using anything other than what we recommend.
Well, Brian, I can chime in on that a little bit too. We do make acceptances for certain situations depending on climate and things like that, but it would involve involving our engineering team to make those blessings. So Brian is right that without engaging our engineering team or CM in general to get a special variance, what's in the manual is what we recommend.
Yep. So now we're looking at a couple shackles, and one says China on it, and it's got a working load limit. So that's that was one part of the requirement. It's got to have a working load limit. But the other requirement per the standard, and I believe I don't know if Rob's still around, but he could probably back me up. You got to have a manufacturer mark on there too, right? By OSHA, right?
Correct. So OSHA actually defers to ASME B30.26, which covers detachable rigging hardware used for lifting. And what it states is name or trademark a manufacturer. So this has been a big conversation for anybody who uses shackles, especially in the industrial side of things. China's a country. It's not a name or trademark a manufacturer. Every piece of rigging equipment, whether it's a hoist, a sling, a shackle, a link, an eye bolt, swivel hoist ring, a crane, has to be identified with name or trademark a manufacturer. The reason being is liability purposes. If that shackle fails, they want accountability and traceability. So if a shackle is labeled China, it does not meet the requirement straight out of the box, brand new. It has to be name or trademark.
I don't know, Rob. Accountability wise, if it says a company name on there, that company could go bankrupt. But China has been around for forever, right? I can go to the king of China. I could talk to him and say, "Hey, dude, your shackle's bad," and I can trust the king of China. That's total authority. He's got to have money. Right?
I'll tell you what, you Google who you need to call in China for a broken shackle and let me know if you get a response.
Okay. I think my phone's out of minutes though. So
yeah, that's one of the biggest things with shackles is the China shackle could be $2 or3 cheaper, but if you right out of the box, it doesn't meet the requirements. So we have to ask ourselves, what other requirements isn't it meeting? Does it have the 5-to-1 design factor? is there a quality assurance program? Is it really worth that extra $2 or $3 to run the risk of something? And it's not, because the second something happens, it's going to get called into question. Well, hey, where's name or trademark of manufacturer? Why were you using this? When was it inspected? All these things are then going to come out. So it's just not worth a couple dollars to use that shackle.
Yeah, agreed.
Okay.
Okay.
Somebody else asked about the amount of truss hanging past the points, and if there's like a standard there. To kind of address that, that's a whole couple hours more of discussion right there. But when we have any kind of load outside of the rigging support, so what we call that is a cantilever. Now, if it's just empty truss, then there's no standard, no specific criteria about how much is too much. It really comes down to a judgment call. What we showed you there, like 3 or 4 feet, that's probably not going to be any problem whatsoever. But if you start putting loads on that, that's when you have a much different situation. So a cantilevered load that is outside the supports, it's something we cover in our rigger boot camp. We do talk about the formulas and how to account for that. But the force on your anchors is going to be much greater than the actual weight of the object you're putting on that cantilever. And the other thing that's going to happen is your opposite side, the anchor that's on the other side of the truss, is actually going to be having a force that's acting upwards against it. It's going to be wanting to lift that end. So when you're cantilevering a load, you have to account for the excessive force on your near anchor, but you also have to compensate for the loss of force on your far anchor, because you could end up tilting the truss up and kicking one end up and causing some problems.
So
you're not certified. Sorry, somebody asked that.
So if you guys would like to do the trivia, just go ahead and put it in the comments section, more trivia or whatever, and we'll see how many people want to keep playing the trivia, because we'll be glad to do it. We got a couple ramped up, right, Mike?
Yeah. Hey, Rob, I see another good question that I think that you might be able to shed some light on.
Mm-hmm.
It looks like Nevin asked this question. I know you do a lot of training up at our awesome neighbors in Canada. And they're asking, interested in the rigging boot camp, do these classes, things taught, apply to Canadian standards that you're aware of? Be looking into it. And let's see, shackles. So can you, first of all, let me answer part of that question.
Mm-hmm.
Don't specifically address Canadian standards in our rigger boot camp, but I love the idea. And during our downtime where we can't have people, I think that would be great to collaborate on, Rob, is to start to include some of that information in there, because we are pretty close to Canada, and I love those folks. So Rob, can you tell us have we looked at anything today or discussed anything today that that would stand out in contrast with reference to the Canadian standards?
As far as like rigging goes, as far as I know, when I go up to Canada to teach rigging classes, they really defer to the ASME standards for rigging. So they really defer to .9, .20 for below the hook lifters, 26 for rigging hardware, .16 for overhead underhung hoist, 21 for lever tools. So they really defer to a lot of that stuff. They actually even defer to some of our OSHA regulations when it comes to construction and rigging equipment used on those. CSA has a couple different regulations for how many hours are required for a technician in order to inspect a hoist, some regulation stuff like that. But we can definitely incorporate that. Our industrial side chain hoist class has that information. There's nothing drastically different. It's more logging. They're required to document all inspections, frequent and periodic. So, if you have a facility that has 100 hoists and they do 100 frequent inspections a day, they're required to log all 100 of those frequent inspections. So certain things like that are slightly different, but for the most part, the US and Canada are pretty much aligned when it comes to rigging standards and things like that. But we can definitely incorporate or talk to the differences between the CSA standards and the US standards very easily. I have most of that data ready to go.
Right.
Awesome. Yeah, and when it comes to other international standards, we have been gathering a lot of information and collaborating with our international partners in CM to start addressing a lot of the EN, the European Union standards. The reason those are pretty relevant is because like I know South America, for instance, they're not part of the EU, but they've adopted EU standards for rigging, things like that. So we have been taking this time to enhance a lot of our classes with a more global perspective to help some of our folks out there in other countries understand that information, as well as acknowledging the fact that, you know, most major tours these days, they don't just tour here in the US. They tour here, then they go across the ocean and they tour over there.
Right.
So a lot of times they take their crew with them. So it's important that crew knows when they move to this other location what kind of standards they're operating under.
And a big note on that, Brian, is a lot of our stuff is already CE certified. You know, a lot of our rigging hardware, shackles, hooks, a lot of our hoists are already CE certified to meet the EN standards, you know, EN 1677 and all those standards for rigging hardware as well as hoists. So our stuff meets that. So we can definitely talk to those points and what the differences are between EN standards and ASME and things like that. So we're definitely in a good situation to discuss those differences if anybody wants to do it.
You know, in terms of hoists, one of the things that that I've educated myself about recently and with our team is the recent changes to the EN standards with the new directive from Germany, the SQP2 directive, which has had a really great effect for us and the Lodestars out there, because now your D8 Plus, which has become so popular. In fact, a lot of people in the US, even though that standard has no standing whatsoever in the US, people want that D8 Plus on there. And the cool thing that has happened with this SQP2 machinery directive from Germany and the EU is that the D8 Plus standard now doesn't require a 10-to-1, it's 8-to-1. And we recently had our Lodestars TUV certified, which is another German body that does certification. You know, these Germans, they do all kind of stuff. You know, they get the SQP2, they get the TUV, they get the BG proof cert. So we, you know, they seem to be a very credible source of making sure things are safe and properly designed. But now the Lodestars are TUV certified, which is something that's very difficult to find in other products. And the SQP2 standard says that now, you know, you can take, we don't have to derate most of our Lodestars, all the, you know, the 2 tons and stuff like that. Nick, do you know about that, about what Lodestar products that we have out there internationally or globally right now that meet that TUV SQP2 standard?
Yeah, well, we're slightly ahead of the game. You can order them right now. Our Model Ls are 1 tons and our Model Fs are half tons can be ordered as a D8 Plus hoist. So it's relatively new, as Brian said. So there's a couple of internal internal processes that we got to work through. But yeah, right now you can definitely order a D8 Plus hoist as a standard Model L or Model F. Obviously, we have to add the double brake and things like that to make it a D8 Plus hoist. But for body size, we used to have to, as Brian said, we used to have to derate our 2 tons to be able to get the 1 tons and things like that. That's no longer the case. Now we can get it out of our chassis of our Model Ls and our Model Fs.
Awesome. 3 questions that came up on the chat that I want to answer. I want to knock these out really quick. Someone asked about the GAC Flex or Steel Flex, or, you know, I call it steel core synthetic sling because I think some of those other terms could be, you know, brand specific. It says they asked about, you know, are you allowed to choke it? And as long as the sling label shows the 3 different configurations, the vertical, the basket, and the choke, as long as it's listed on there, you can do it as long as you account for the capacity that goes along with that. If it doesn't list chokes or says do not choke, then yeah, you would want to avoid that. Someone else asked about cross-loading when I mentioned cross-loading. So I've got a shackle here. Cross-loading would be when I have a force acting like this on the shackle, right? So ideally we want our forces acting like this vertically from the pin to the bell. We can also have forces acting up to 120 degrees along the bell, right? Without reducing working load limit at all. We can have a 120 degree angle here. So like, you know, like that. But when the shackle would turn like this and our hook is here and our sling is there or whatever, and we're pulling it apart like that, that is what we call cross-loading, and you want to avoid that at all costs. And then side loading would be if the shackle is in a fixed position, right? So the shackle can't rotate at all. It's stuck in that orientation, and I'm pulling to the side. So Rob, maybe you can tell me, what if I had a side-loaded shackle? So maybe I put that into like a fixed object, and I'm pulling it at like this 90 degrees from vertical. What kind of rated load am I going to be looking at, or what kind of load reduction am I going to be looking at there?
Usually the rule of thumb is whenever you go outside of the 120 degree included angle of the shackle, you reduce your capacity by 50%. So you lose 50% of the working load limit of your shackle. It's designed to take that load for safety reasons. So when we manufacture the shackle, we understand in some circumstances that shackle might flip during the lift, and you have no control over that. So you're going to reduce your working load limit by 50%. But chances are when you get that shackle back down to the ground, it's going to be distorted, bent, twisted, cracked, and it's coming out of service right away. So it's kind of a one and done shot. The second you do it, you can pretty much guarantee you're not going to be able to use that shackle anymore.
Somebody else asked, does CM manufacture products in China? Or we do have factories in China that manufacture products out there, but our Lodestar line is made here or assembled here in North America. We have our chain plant where they make all the chain is in Lexington, Tennessee. Our forge, our main forge area is in Chattanooga, Tennessee. That's where all the hooks and the shackles are made by our forge. And then our Lodestars are assembled in Damascus, Virginia. So,
yeah. And if I could speak to the manufacturing plant, we do manufacture manual hoist in China. It is our manufacturing facility. And I get asked a lot the difference. Well, you say we can't use China shackles, but you manufacture a product in China. Well, the difference is it's our engineering, it's our design, it's our product. It comes through our quality assurance program. It also has Columbus McKinnon's name on it. So we're not going to have something manufactured that doesn't meet all relative standards as well as meet our standards. We even go as far as getting HMI certification on our imported products from China through our manufacturing facility, which is a third-party certification, which even guarantees even more that it meets or exceeds normal industry standards. So we do a lot to ensure that our product is top-of-the-line quality. Naturally, it's manufactured overseas, so we can distribute it at a better price point.
Yeah, absolutely. So, Brian, I'm going to change directions here for a minute. I've noticed that there's at least a half a dozen questions about dropping shackles. Like, is there a certain height that a shackle is still okay? I don't know if Rob can talk to this at all, or if we even have a definitive answer to that. But it looks like there's quite a few questions about what to do with shackles when they're dropped. Is there a certain height requirement? Things like that.
I'll leave that one to Rob.
So
that was a hard one.
Yeah, no, I get this question a lot. I get it a lot from industrial. I've heard it a lot through the entertainment classes that I teach. It's kind of an old myth. It's one of those old wise tales out there. Oh, if you drop a shackle and it hits the ground, you can't use it anymore. Nothing says that. Nothing's written in any standard or in any regulation that states that. Now, that might be a company's policy. Hey, if you drop a shackle, it hits the ground, take it out of service. So be it. But the rule of thumb is if you drop a shackle from height, whatever that may be, 2 foot to 100 feet, that shackle needs to be removed from service and inspected. And you go through the removal from service criteria to inspect that shackle. Dents, twists, distortions, bends, cracks, or elongation in any load-bearing component, so the bail or the pin. Do the threads fully engage? 10% wear, and you go through your removal from service criteria. If you deem that shackle to have any of those removed from service criteria, then absolutely that shackle's trash. If you don't find anything wrong with that shackle and you're the qualified person on site and you determine that shackle's safe for continuous use, then have at it.
Yeah.
Nowhere is there anything written that says if it hits the ground from height, you can't use it anymore. You just need to inspect it and continue the safe use and application of that shackle.
Okay. Very good. Hey, Mike, do you think we can roll a trivia question?
Sure.
Let's do 2 more trivia questions. Yeah.
Cool.
All right.
Here it's coming.
Just for the heck of it. Brian, you want to read it out?
Sure. What is the rated capacity of a Model L Lodestar hoist? Ignore the picture, the image on the side of the screen. I think that goes with a different question. What is the actual load in pounds that our Model L Lodestars are rated for? Oh, looks like we went to another question.
Did we mess up the trivia now?
Yeah, we skipped over to another question.
See, we got off script, Brian. I told you.
So for those of you answering that first question about the Model L Lodestars, the maximum load in pounds is 2,204. If you read the capacity label on the end of the hoist, it'll say 1 ton, and then next to that it says 1,000 kilograms. So in pounds, that's actually 2,204 pounds. So make sure that if you're doing load testing or anything, you're basing your load testing criteria off of that that load testing.
Yeah, it's important to look at that sticker on the side for sure.
Hey, Rob, we talked about burlap earlier, and I was wondering, what are some good alternatives to that burlap?
Yeah, so in industrial, we prefer cut protection, engineered cut protection. So there's a couple different things out there. There's a Dyneema sleeve, which is basically fire hose on steroids. It has a cut protection rating of 25,000 pounds of cut protection per square inch of contact. We have magnetic corner protectors. We have engineered pads. We have wire mesh. What you really want is something that exceeds normal sling. So a lot of times people will stack up sling webbing. Well, now you're just cutting through the same material as normal. I know in entertainment, you guys are real big on the burlap, but it needs to be layered in a way that will protect that sling from a sharp edge. And one of the hardest things is to define a sharp edge. So if you want to just address that real quick, I think that would be good for the audience too.
Yeah, and when it comes to the fire protection rating on that, we got to in that they have to be retreated after so long. So whoever is providing that, so that's who would tell you how long that product will be valid for.
Yep, absolutely.
What was that second trivia question that we had up from before?
I'll tell you what, Brian, let's do one more trivia and then we'll wrap it up here. But let's give them one that they haven't seen yet.
Yeah.
Is that the one we showed before or no?
Yeah.
No, that's the correct one.
That one. They don't get to answer that one. What's the next one?
Approximately
There
how
we
much?
go.
Okay.
Go ahead and read that one, Brian.
The grade value of stack chain, or as some people call it, deck chain. And stack stands for special theatrical alloy chain. We want to know what is the grade associated with the strength of that chain.
All right. So looks like our stream might have frozen, Brian. So we might have exceeded our limit here.
Okay.
So let's go ahead and just wrap it up. Oh, looks like some people are coming through. Never mind.
Yeah.
All right. Very good. All right. So it looks like the majority are saying C. Is that the correct answer?
I wasn't expecting so many right answers on this one because, as far as my experience in entertainment goes, I didn't know about different grades of chain until I met Rob Bruno. Yeah. I didn't know what grade 80 or grade 100 meant, But Rob, while we still have that trivia question up, can you tell me, are any of those grades not rated for overhead lifting?
Yep. So grades 43, which is also known as high test chain, and grade 70, which is known as transporter binder chain, per OSHA and ASME are not authorized for overhead lifting. Grades 80 and 100, because they're Herc alloy steel chains, are the only chains authorized for overhead lifting.
Cool. Well, thanks.
Very good.
Yeah, I see a lot of comments talking about, looking forward to the next one or what are we doing next. And trust me, we are talking about that behind the scenes right now about what the next really cool online thing is going to be. So, join our Facebook group, CM Riggers Forum, jump in there, keep the conversation going, talk amongst yourselves as well. And let us know what kind of thing would you like to see given the, what we can do online. And Nick, why don't you send everybody off with us?
Yeah, absolutely. And to piggyback off that, Brian, I think we've learned a lot on what to do next time, even make it more interactive. So to Brian's point, what topics would you like to see? I mean, I think we may have found out that we bit off a little more, too much topics for this round to be able to get that interaction going and stay on time. So we'll probably scale it down a little bit. But what's the next thing you guys would like to see? That's kind of what we're looking for. And we'll be sending out a survey to kind of hit you guys up to get the feedback. Again, sorry that we couldn't play live trivia and crown the smartest rigger in the room, but we'll definitely figure out what went wrong there and hit that up next time. But again, from CM, from Harp, from everybody, we sure appreciate your guys' attention and your interaction, and hope you enjoyed it as well. And we'll see you next time.
Absolutely. Thank you, guys.
Thank you for joining us. And the guys at Harp, thank you so much. Why don't you send us off?
Oh, yeah. Thank you, guys. And definitely tune in. Tune in to our Facebook as well as CM's. See what we're doing. We might be doing something a little different random days, showing you behind the scenes here. So, yeah, just stay tuned for our future trainings. Thank you.
Thanks, everybody. Have a great day. Stay safe.
Thanks, everybody.